Okay, guys, so we're finding the arc length for part A, the arc length function for the function r of t equals 5ti plus cosine tj plus sine tk, and we're going to use it to reparameterize r of t in terms of s, basically. So in terms of arc length, that's what we're calling s. So this is the formula. S of t equals integral a to t magnitude r prime u du. So you look at that formula, it tells you what to do. You don't need step 1, step 2, step 3. Just kind of examine that formula from the inside out. What do you need to find? R prime of u. Okay, so r of u is just this guy with u's instead of t's, right? So what would r prime of u be? So just 5i minus sine uj plus cosine uk. So there's r prime u, and then what does the formula say to do with that? We're looking at it from the inside out. So what do I mean by that? Well, the innermost grouping symbol, really. R prime u we found first, and then magnitude, right? Next. So, okay, we can do that. The magnitude of r prime of u, what is that going to be? Square root of 25 plus, yeah, let's go ahead and show the work here. Sine squared u, I mean the negative disappears, right, when you take this, so I didn't bother putting it in there, plus cosine squared u. And then somebody already said it. What is sine squared plus cosine squared? What does that turn out to be? Just 1, so you get root 26 in there. Everybody agree with that? Okay, let me create some screen real estate here, so I don't have to scroll down. Okay, so filling in the formula, we get s of t equals the integral from, okay, a we already said was 0 in this case, right? T equals 0 to t of what? Root 26. That's the magnitude of r prime of u. Root 26 du. But we can evaluate that, right? So let's go ahead and do it. So what's the value of that integral? Well, okay, t times root 26, right? Does everybody believe that? Root 26 times t? Yeah? So I skipped the evaluation, but if you evaluate it, you get root 26u evaluated from 0 to t, and so that just becomes root 26t. Does everybody buy that? So let me be clear here then. That means I'm going to drop the function notation on the s. This is s of t. I'm just going to write it as s. My s's look like 5s, unfortunately. So that's s equals root 26t. So the idea is we could solve for t in terms of s, which is what you told me to do, right? So what would t be equal to? So s over root 26, that's an s, over root 26. And then if you want to parameterize r ultimately in terms of s, then you could just replace the t values with s over root 26. And so that gives me r of s is equal to what? 5. What does that become? 5. 5. There's a 5 and there's an s. So 5s over root 26i. What's the next one? Cosine of s over root 26 times j plus sine of s over root 26 times k. So, and I want to point out, both r of s and the original r of t graph to be the same curve. In other words, as a whole, they contain the same set of ordered triples, right, that make up the curve. But the neat thing about r of s is, you know, if you want to know what point lies 5 units away from the beginning point that gets generated when you plug in t equals 0, you would just plug in 5 for s. Yeah. Well, yeah, the part I didn't show, so here's the step I didn't show. That's the step you want, right? So when you integrate root 26 with respect to u, you get root 26u, right? Okay, so root 26 times u, but it's evaluated from 0 to t. Yeah, and you can actually leave the constant of root 26 on the outside. That's the easy way. So if you evaluate u from 0 to t, okay, you plug in the t first by fundamental theorem of calculus, and then the u, but that just becomes root 26 times t minus 0, which is root 26 t. Okay? And by the way, anytime your integrand is a constant and you have something of this form, 0 to t, it's always going to be whatever the constant is times that upper limit, right? If the bottom limit's 0.